Now we will study special purpose PN junction diodes. That means how we can use PN junction diode for different purpose. First one is your Zener diode. Second one is your Photodiode and LED means light emitting diode, and fourth one is your solar cell. Already you must know about your solar cells, which converts solar energy into your electrical energy, and different applications also. So main important topics are Zener diode, Photodiode and LED. First of all, we will discuss Zener diode. What is the symbol of your Zener diode? This is the symbol of Zener diode. And remember, what is its principle? Zener diode works on the principle of your reverse bias. Already we have discussed in many previous lectures what is the function of your reverse bias and forward bias. So remember, Zener diode works only on your reverse bias. And another important property is Zener diode is used as an, it is also used as a voltage regulator. That means if we can use the Zener diode, then we can regulate the voltage, or the output voltage can be regulated with the help of your Zener diode. Now, second, that is a photodiode. What is a photodiode? Photo means light. So, photodiode is fabricated with a transparent window which allows light to fall on it. And photodiode works on the principle of reverse biasing. Now, what is its working and what is its symbol? This is also a special design PN junction diode, but this is named as your photodiode. Means light falls on this PN junction diode. So, how it works? When it is in your reverse biasing, then a reverse current will develop across the junction, and that current or that reverse current will increase with the increase of value of your this light or incident light. That means, in other words, we can say when H nu is greater than your AEG, means what is your H nu and what is your EG. H nu is the energy of your visible light, and EG already we know this is your forbidden energy gap. This is the most important principle on which the photodiode works. Remember, when H nu is greater than EG, then the value of your reverse current will increase as the increase in the value of your incident light. Now, if you study the VI characteristics for the photodiode, then what will be its nature? This is in a reverse bias. Then like this, for the different intensities, because already we have told it depends on the intensity of incident light. Now come to the next. That is a LED, which is called as a light emitting diode. This is also related with the light, but this will emit light. So the symbol of your LED, this is also your PN junction for special purpose. So this will emit light. That means you have to mark the direction like this. Clear? But LED works in your forward biasing. So this will be connected to positive and this will be connected to your negative. Now, what is the working of the LED? Already we know, during your forward biasing, the majority charge carriers from N sides, means electrons, will drift to the P side, and the majority charge carriers, which are your holes, are drifted to the N sides. Similarly, the minority charge carriers will concentrate, as a result of which the depletion layer will be formed, and the depletion layer will be thin or reduced, or the barrier potential will also decrease during a forward biasing. So, for each combination during your forward biasing, what will happen? The electron will fall from higher energy state to your ground state. That means, in other words, we can say when it jumps from higher energy state to ground state. That means at that time H nu is equal to your Eg. The total energy is equal to your forbidden energy gap. But remember, in case of your photodiode, H nu will be greater than your forbidden energy gap. So, when H nu is equal to Eg, then what will happen? At that time, a photon will be released. Means light will be released. That's why we say generally कि LED emits light, but a simple PN junction diode will not emit light. Clear? Now, different colors of LEDs are available. That will depend on only on the nature of the materials used. Generally, we used gallium arsenide or gallium phosphide, or we can use gallium arsenide and phosphide. When we used gallium arsenide, then the color of the LED will be your infrared combination. And when we combine gallium phosphide, then it will be a red or green. If you combine all these gallium arsenide phosphide, then red or yellow. Now, if we want to study the characteristic curve for your LED, then what will be its nature? We know LED works in a forward biasing. So, this is in a like this. Maybe this is your red, green, yellow, white, etc. But the nature of the graph will be like this. And you have to plot in this quadrant because of the forward biasing. So, this is all about your special purpose of your PN junction diode.